I'm going to introduce you Jamieson. Jamieson is a geologist with experience in gold exploration and open pit mine geology. He worked for 18 months in exploration at Norseman in Southern Goldfields and 2 years at Ravensthorpe Nickel laterite mine. He has now been with Datamine for over 2 years and supports and specialises in Studio RM, Studio Mapper, and ore controller software. Welcome, man.
So great to see everybody today. Some of you may have seen my name in support. Like T, I apologise if I've ever given you a bum steer. I hope not. But I will be telling you about Ore Controller, a little bit about what it does and what is on the horizon. On the Datamine website, if you're compelled to go and find out more about Ore Controller after my presentation, you'll actually find it under Operations Software. Because at this point, we're at the intersection of geology and operations. When we're using Ore Controller, we're classifying materials in the pit. This is ore, this is waste. We're thinking about how we're going to mine it, what the dilution is going to look like. We're deciding where it's all going to go. And we're distributing that information to the relevant stakeholders, engineers, surveyors, operators, whoever else needs to know. Okay, so the problem, and it's not a bad one to have, is that if you consider a 1.2 grams per tonne in a 260 tonne truck and a price of $2,500 US per tonne, each truckload of ore can be worth up to $30,000. So there's a lot at stake. You want to be confident that your ore is ore, your waste is waste, and you're not mixing them too much. If I was to give you a moment to think about what qualities you want in your grade control system, I hope some of the keywords that might pop up are flexibility, quick and easy, repeatable. This could be achieved by a very big, very complex series of macros and scripts, but they require time and expertise to create and maintain. Let's face it, geologists aren't software programmers. Which brings me to Ore Controller. So the idea of Ore Controller is that it's built on Studio's proven modelling and estimation base, whereas Studio RM is a sandbox. You can do anything with a little bit of imagination. Ore Controller is breaking down your grade control system into a guided workflow. And so, some of the qualities of Ore Controller here, it's a system accessible by multiple users. It's managing the storage of your data so that geos can focus on the technical stuff they were trained to do, not copying and pasting files to the right place, making sure they're named correctly. The grade control workflow is always somewhat the same. So you've got planning and planning a sampling program. Logging, sampling, assaying, geological interpretation, blast displacement, which we've heard a little bit about, and we'll see how that fits into Ore Controller, distributing that information to the relevant stakeholders, and then judging yourself on how well you did that at the end of the month. The devil is in the detail, though. Each site is always going to have their idiosyncrasies. Ore Controller, though, is highly configurable. So we can change it to capture each site's workflow and unique requirements, any weird and wonderful calculations that you might have, a multitude of materials and destinations without pigeonholing you into our idea of a grade control template. So I'll show you a quick little video which just demonstrates a little bit about what Ore Controller does. Here we're just watching me knock up a quick dig plan. Please don't judge me on the quality of it. And just seeing some of the things that Ore Controller can do along the way. So as we're creating our dig blocks, we can compare it with a topo surface. See if some of that material has already been mined out, and that will be considered in our tons and grade evaluation. So we're just putting some rough strings in there. Don't judge me too harshly. Now we can set a custom face profile. Let's take into the consideration the geometry of your ore body, and we'll see what that does in a little bit. So, you know, you can have different options for different angles there. I've chosen 60 degrees. So now we come on to evaluating tons and grade. So it's doing a few things at this point. It's converting those strings into wireframes, clipping that with our depletion surface. So we can set it to model a little bit high in case your pit floor hasn't quite been dug to specification. And so, you know, any additional material that's sitting on top of the bench will be factored into your evaluation. Okay, so it's automatically named all of our blocks there. You can see, you can sort of view them one by one. We've got a couple of neat little tools for assessing misclassification or the material breakdown inside your ore blocks. So, you know, ideally you want all of your categories on the left to line up neatly with what you've got on the right. That isn't quite so with the one I've done here. And so you can go back and play around with it and have another go. Okay, and we'll see how that face profile comes into play here. So instead of just projecting them straight up and down into vertical wireframes, it's projected them at the angle that I set. And so when you're designing your dig blocks, you can have a think about how you're going to approach digging this to minimize dilution. Going back to a presentation last year by, I think, James Ball at Northern Star, he had a little figure in his presentation showing, you know, if you mine this coming from the hanging wall direction, you can expect about 12% dilution. Coming from the wrong direction, you know, that increases to about 24%. I forget who that was attributed to. But here you can account for that when you're designing your dig blocks. Besides that, Ore Controller will do some clever calculations, tell you how much ore loss and dilution you have. So internal dilution, contact dilution, ore in waste, and you can quantify that and put a dollar figure on. It'll automatically put that into a plot according to a template. So again, you don't need to muck around with creating that report. And that is it. It does more besides that. If I can name one additional tool, you can have independent toe and crest strings when you're designing that mark out if you've got a particularly complex ore body. So just a few of the neat things the Ore Controller does. I mentioned before that there is some data management going on behind the scenes. So it works in tandem with Minetrust. You'll begin hearing a lot more about Minetrust as we roll it out to some of our other softwares, Studio RM, Studio Mapper, just a couple. But basically, Minetrust is storing all of the input and output data that will be required for Ore Controller. So Datamine files, any reference data you care to import, parameters, templates, custom macros. That's all managed behind the scenes and stored on a central database. If we look at this diagram here, this is how Ore Controller is breaking down your workflow into a series of activities. Each activity is defined by a number of inputs you'll see on the left. At the top, we have a context. So, you know, each activity is taking place within a pit, a bench, a blast, any other way you break down your operations. On the bottom, we have, you know, the action that is being undertaken. Typically, there will be some Studio Core processes or commands. And on the right, the output data that is being generated, and typically that will become the input data for the next activity. You'll see on the left, we've got one of our inputs in red. If you are missing any of the information that is required for that activity, it will not let you proceed. So that is how part of how Ore Controller is managing your workflow. We can configure it to match what you need, but once it's implemented, it's a rigid workflow that can't be broken by anybody on site. This just illustrates a little bit about how Minetrust is working in the background to manage the data. So we can have multiple users on the left, each on their own desktop. connected via the network to a dedicated server which acts as the central database, and that is storing all of the files that you're using in Ore Controller, as well as the metadata. Now, the metadata includes, previous version histories, the file history, who checked out that file, what they did and when. It's a useful troubleshooting tool. More than once, clients have come and said, my system isn't working. We go and look at one particular file and you can see on this date somebody checked it out and checked it back in and it was half its size. So you can easily pinpoint where things have gone wrong. Besides that, we can retrieve and view previous versions, and we can roll back if something has gone wrong. Okay, now, this ties in nicely with what Augment has to say. AI blast displacement is somewhat the rage at the moment. Previously, Ore Controller has had a level of interoperability with BMT, in that it would automatically export the required input for that software to a predetermined location and then retrieve the displaced dig strings. So, you would create your dig plan around your in situ model, export that to BMT, it would displace those strings, and then you would take them and, distribute them, do whatever you want with them. Now things can be a little bit different. So development is currently happening to neatly package up ore movement policy completely within the Ore Controller interface. So no need to go into a separate package and then import those things to Ore Controller. It'll all happen within the Ore Controller interface. It's a natural progression. Ore Controller already creates some of the required input data for OMP in the form of the in situ grade control model. But the flexibility of Ore Controller means we can easily configure it to collate all of the required data for OMP, run their workflow without having to leave Ore Controller, and assisting you to unlock the potential benefits of their proprietary muck pile block model in quantifying and managing blast displacement when you're planning your mining. Just a little bit about the what you can see in the pictures there. So Ore Controller will automatically calculate the difference between the pre and post blast topos. You can see a heat map of that in the bottom left corner there to guide you as you draw your pre and post blast outlines in Ore Controller for ore movement policy. Also on the roadmap, automatic wireframe updates. So implicit modelling in Studio RM is now quite mature. It's something we do continue to push, and you'll hear a little bit more about it when my colleague Joe talks about Studio Geo a little bit later today. And so those implicit modelling algorithms will now be made available in Ore Controller for integration into your workflow. Previously, you'd model your wireframes in a separate package, and you would import them as reference data into Ore Controller for volume modelling. Now you'll have the ability, the concept is that a user will use Studio RM for configuring their implicit modelling parameters. That will be packaged up within the Ore Controller controls. And so with Ore Controller's sort of blast scale grade modelling concept, you'll have the ability to rapidly update your wireframes on the fly as you conduct your grade control modelling, meaning you'll have access to the most up-to-date data, and rather than lengthy processing times for your implicit models, I'm told these models took about 90 seconds to build. Now we also have a partnership with MineStep's Ozone for automatic ore zone and dig line optimization within Ore Controller. Again, coming back to James Ball's presentation last year, he spoke a little bit about mine shape optimization. I think one of the examples he gave was he tasked 3 of his team with varying experience levels to mark out the same material, As you would expect, the results were drastically different, about 50% in tonnes across the three and 44% difference in ounces. And Ozone's optimization negates that. So you can optimize your mark out according to whatever your operational requirements may be. Tonnes, grade, avoid deleterious materials, compare scenarios, and there are going to be consistent results from multiple users. Everybody should be aligned on what the priorities are. Making markouts can be time consuming, and when you've got multiple users, the results aren't repeatable. Okay. And so in conclusion, this slide is a bit of a shameless plug, but at the end of the day, it is about tonnes, grade and money. Increase the first two and hopefully the third will follow. And so what I hope I've shown you in this brief slot today is how we're leveraging our own class-leading modelling tools and forming relationships with other industry-leading companies to give you a unique grade control solution. Thank you very much.
Hey mate, Darcy here from Atlasine. The blast movement looked to be exclusively a blast by blast process. How do you manage where you've got blasted stock adjacent to the blast in question that's just gone off and you're about to design? How do you manage the impacts on that broken stock sitting up against the blast that's just gone off?
On adjacent in situ?
Because you would have a block out for the blasted stock that's sitting there.
Mm-hmm.
The adjacent shop.
Mm-hmm.
How would you manage the impacts? Is there a workflow that updates that block out as well? Or?
So at the moment, in Ore Controller, you're modelling each blast at a time in situ, and so there's a neat boundary between those two. I suppose that's perhaps an ore movement policy thing, because when you're displacing that material, there is going to be some overlap. A little bit of material from blast A is going to go into blast B. I think, before you're combining those blasts together into a single grade control model, it's all separate anyway. So you can, take it blast by blast. I think that is a challenge when it comes to combining it all together and doing a reconciliation. And that is something that, the developers are, considering. I don't know what the solution is, but, that is something that we're looking at and developing at the moment, how to handle that.
Yeah, awesome. And sorry, just another one. Reconciliation, how does it go about in this software package? So reconciliation in Ore Controller typically consists of combining all of your blast models together. And then it's relatively basic, just slicing those between two surfaces. So, last month's end of month, this month's end of month, looking at the tonnes and grade between those surfaces. We can add a resource model in the mix, for example, and see how the grade control compares to the resource in that period. You can compare, other models in there as well.
Hey James, Leon from Augment Technologies. Great preso, mate. Really appreciate the shout out for us. But I might just jump on your point, mate. In the muck pile block model in OMP, you can combine those two post-blast muck pile block models if they were next to each other and you did that there. So they won't expect the workflow, that will be Kale. But I suggest please have any yarn to him because he'll be able to give you an answer. Thanks, bud.
Thanks.